First of all, I want to thank Ross from AWS for organizing this community track. Thank you so much. All talks in this track are from the community. And the idea is for us as community members to share what we've done, what we've built, and what we've learned. And hopefully to inspire all of you kind of to do the same. So welcome to our talk. It's called The Evolution of Serverless Architectures from the Lens of the Community. And this talk is a celebration of the community and all things serverless. So we will share some tips and tricks. We will talk about how far we've come as a community and hopefully get you more excited about serverless architectures. I think one takeaway I want you to take with you when you leave after this session is that our serverless community is young, it's vibrant, it's very diverse, it's very welcoming. It's easy to join a meetup group, it's easy to contribute an article online, it's easy to get into a serverless conference, tweet, and engage with other people. Serverless technologies are still new, right? Only a few years old. So there is a lot of opportunity for everyone. You can become a serverless thought leader today and make a huge contribution to the rest of the community. But I guess first we should set the scene and kind of mention who we are. Thank you, Sam. My name is Peter Zbarsky, and I'm VP of Engineering at a company called A Cloud Guru. And if you haven't heard of us before, Sam will talk a little bit about our company and what we do in a minute. My background is in computer science. I got my PhD back in 2009. Seems like decades ago now. But for the last couple of years, I've spent kind of focusing on serverless architectures. I'm also the author of a book called Serverless Architectures on AWS. It was published by Manning this year, and a co-author of an upcoming book called Serverless Design Patterns that I'm co-authoring with Tim Wagner and Yochai Kiryati. And this gentleman next to me is Sam.
Hi, everyone. I'm Sam Kronenberg, and I'm one of the founders of A Cloud Guru. If you haven't heard about us, we're an online learning platform, and we train engineers in all things cloud, basically. And we actually built our platform technology entirely serverless. In fact, we're an entirely serverless company. And I feel like I need to provide you guys with some proof. So here it is. This is a screenshot of our EC2 dashboard.
Yeah.
That is our production environment. Thank you.
Yeah.
And I'm finished, I'm out, and I'll see you later. So I guess interesting fact about me, prior to founding A Cloud Guru with my brother Ryan, I worked for Microsoft, and I was a developer on Windows 7 and Windows Vista. I worked in the core file systems group, and in that group, my major focus was the disk defragmenter. So I actually wrote defrag for Windows 7. I got to throw the whole thing out and start it again from 0 lines of code, which was incredibly satisfying because it needed to start again from 0.
Yeah.
And part of what I built was Windows Server. All of that code shipped in Windows Server. So I'm definitely a convert to serverless. I actually spent a significant portion of my career building server software like Windows Server. So I think we're an interesting case study, A Cloud Guru, because for businesses today that are looking to invest in serverless technologies, we've been to the future and we've come back. Over the last 2 years, we've built one of what I would say is one of the world's first entirely serverless web platforms that operates at scale. We were pretty early adopters in this space. We launched our platform in 2015, before the term serverless was really being used, and before you could even call Lambda from the web, before API Gateway was available. So, in the last 2 years, we've been through the journey that a lot of companies, a lot of people are starting on now, trying to go entirely serverless and move into serverless. And I think we've learned where serverless technologies have been a massive accelerator and where they've actually brought really real challenges and been pretty painful. So, we were early adopters in 2015, and I think one thing that we did was that we proved you could build responsive web applications this way, not just back-end processing pipelines in AWS, hanging lambdas off things. But, our platform is a rich media application. It's, we've got a web app, we've got a mobile app, and it's entirely serverless. The site is literally just static HTML, JavaScript, and CSS. It's actually deployed on a CDN. It doesn't get served by a web server at all. It's completely stateless. It loads in the browser, and then it connects through to our AWS backend through API Gateway and into Lambda. And that's how it gets the data. And towards the end of the talk, I'll show you, I'll take you through some of what I think are the opportunities that serverless brought us and some of the challenges that it presented to us. And I'll show you our architecture. And I think, so interestingly, one of the reasons that we chose to build serverless in 2015 is because we were a bootstrap startup. So we didn't have any funding. We didn't take any funding early on. So we had to do everything ourselves. And in the early days, ourselves was me and my brother Ryan. And so we knew scaling was going to be a challenge for us. So we actually chose serverless technology because it had the promise to let us scale incredibly, but without having to actively think about it while it's running. So we didn't have an ops person because we couldn't afford it. I needed the platform to scale with customer demand and not have to worry about whether we had enough capacity provisioned at any given time. And we couldn't monitor the site all day because we had to sleep. Right? Like, I had to go to bed, and I needed to make sure that while we slept,
sometimes
the site would still run. And it worked incredibly well. And through that architecture, we've scaled out to 400,000 users worldwide now, and literally millions of people visit our site every month. And I've never had a single moment in the business where I have thought to myself, oh, things are starting to run slow. Or, are we under-provisioned? Do we need some more capacity? That's just never been a problem because of this architecture. And we have this internal mantra at Cloud Guru, which is no servers. Right? So that EC2 dashboard at the start, like, it wasn't a joke. We don't let people spin up EC2 instances in the company. That means we don't run our own build servers, for example. We use managed CI and CD pipelines, and they handle that for us. I guess an arbitrary rule like no servers might sound silly. Like, why? Why would you do that? But it really encourages the culture internally of outsourcing everything that isn't our core value. Like, our team should be focused on building a great learning management platform, learning experiences, and not on running build machines.
That's right. And look, we started talking about serverless early. In 2015 and early 2016, we wrote some early articles on what we were doing and what our architecture was. And they went viral. And this is how we knew that we were onto something. People, I think, were starting to see the value of serverless and what we were doing. So we made a decision to start teaching serverless to the world alongside our usual kind of standard AWS training.
Yep.
Thank you, Sam. So yeah, look, we believe in serverless architectures. We then spent a bit of time working on this book, Serverless Architectures on AWS. It outlines some important principles, patterns and architectures that you should know about. And it describes how to build basically an end-to-end serverless web application.
He says we, but he wrote it. I didn't write any of it. And they actually took my name off the cover, because apparently if you don't contribute to a book, you're not allowed to have your name on the cover.
Wow.
Crazy.
Lessons learned, lessons learned. Yeah. Our friends, and actually I think some of them are in this audience, also produced a number of great video courses covering serverless technologies. And you can find these on our platform. Some of them are great, like if you are looking to get into serverless. Some of them are useful if you already have a bit of experience and wish to learn technologies such as GraphQL and how they interoperate with serverless tech as well.
So that's enough about us. But if you do go to reinvent.acloud.guru, then you can get an extended kind of free trial to try out these courses.
Yeah. Oh, there is one more thing about us. Yeah.
Yes.
So because we weren't busy enough as it is with our startup, we decided to start another little venture. So we decided to run a conference dedicated to serverless technologies. And look, we're not professional conference organizers. We're not really. We are developers. And we thought, how hard could it possibly be to organize a conference? Turns out it's hard. Okay, it's hard, but it can also be a lot of fun. So we organized our first conference in New York. It
also turns out that New York is hot in May.
Oh, yeah, yeah.
And when you organize venues, you should find one that has air conditioning.
Yeah, we forgot about that little point. So yeah, we organized the first conference in New York. It was May. Yeah. We didn't know whether anybody would attend, but luckily 250 people showed up. Amazon was actually our primary sponsor, which was great. Thank you, Amazon. But yeah, we forgot about the air conditioning. So that's
it just showed how excited and passionate the community were because everybody stayed, and it was like a 90 or 100-degree day in this tiny room with 250 people.
That's true, but there was ice cream and beer, so that's okay.
True. Yeah.
We then ran our conference in Tokyo, we ran it in London, and each time the conference grew and more people attended. So then in 2017, we ran our first conference in Austin. Then we went back to our spiritual home in New York, and luckily this time we had air conditioning and heating, and the temperature was perfect. And then finally we had our last conference for the year in Tokyo. And you can find all talks online. You can just go and watch them. They're a lot of fun. And I just want to say that each time we have run Serverless Conf, we've been astounded by kind of the passion that our attendees have had for serverless technologies. And we've had companies like Amazon, Microsoft, Google, IBM, Capital One, Verizon, iRobot, and many others come along, sponsor, and participate. So it's not just us who's excited. I think a lot of companies joining in.
A lot of big companies, yeah.
Yeah.
So, you know, there's people, all different walks of life in here, and I think it's just important to go back just a little bit to the evolution of serverless and set the scene. Humble beginnings, right? So there were some early plays in the function as a service space before Lambda. There were things before Lambda, but they went pretty mostly unnoticed in the mainstream. So in my opinion, the serverless revolution that's kind of hitting us now started with the launch of AWS Lambda. That was the game-changing product. And I still remember talking to Pete a few years ago before Lambda and having this conversation where we were .NET developers at the time, right? And we just and we just wished that we could give a cloud provider the code for our API and have them spin it up, manage it, execute it, scale it for us. And we were like, wouldn't that be amazing?
And I said, Sam, that'll never work.
And when I heard about Lambda from my brother Ryan, I went to Pete and I said, I think this is it. I think this is how it's going to happen. This is really, really cool. And that's how we got into it. So, okay, so what is serverless, right? Is serverless just Lambda? So strangely, there is still debate about this because it is a seriously vague term. When you define something by what it's not, you aren't describing what it is. I think this is why everybody is still talking. Like every talk you see on serverless out there starts with, so what is serverless? So this is my take to define that. So I think the term can obviously be attributed to the growing popularity of function as a service technologies like Lambda, which are often described as serverless. But if you look at the way people are actually using or building serverless systems, there's a lot more to it than just that. So in my view, serverless is actually a theme. It's an approach to building applications, and it's comprised of compute and patterns. So there are these serverless compute technologies like Lambda, and then there are serverless architectural patterns. These are like patterns for crafting systems without any traditional backend servers, and generally that means integration with third-party services, right? So whether they be native cloud services, you know, Elastic Transcoder and all the different things in AWS, or whether you're talking to Auth0 or WebTask or Stripe or PayPal, all these other rich web services out there. And the real power of going serverless comes from that integration with the other services. It's hooking functions into serverless to orchestrate these pipelines. So this has been referred to by people much smarter than me as a service-full approach, and I really like that term. That was coined by Patrick Dubois, where cloud services are really heavily leveraged, and serverless compute is just the last mile that kind of weaves it all together. You've got all the services you're using, and you just weave it together with functions to build your valuable product.
That's right, yeah. One of my favorite definitions is by T.J. Holloway-Chuck, who is the creator of the Apex framework. And he tweeted that serverless does not equal functions, right? FaaS equals functions. Serverless is on-demand scaling and pricing characteristics not limited to functions. And I really like the definition myself. And I think we're seeing more people kind of agree to it as well. And I mean, maybe for that reason, perhaps Amazon now refers to more technologies as serverless
like
rather than just Lambda.
Athena is a serverless SQL service,
yeah,
right?
Yeah,
according to Amazon.
Yeah. And look, it wouldn't surprise you that obviously interest in serverless has grown steadily over time. That graph on screen shows that serverless began to grow steadily from about, kind of the interest in serverless began to grow steadily from 2016, from January 2016. And this is maybe because Amazon began using this term. Yeah. It's interesting that related queries that people have when they search for serverless are also AWS and Lambda. And actually, interestingly, speaking of Lambda, you can see that both serverless and Lambda are following the same trajectory in terms of searches and interest over time. And in fact, Lambda has more people searching for it than serverless. Okay. But it is really good to see that both are growing quite quickly. Look, our community is passionate, and it has certainly made an effort to build frameworks, libraries, services for and around serverless technologies. I mean, just take a look at these different hosting and cloud execution technologies available. So I took this list from the below GitHub repository. There's a link. So please check it out. And if you feel that the list is missing something or is a little out of date, I'm sure the author would appreciate a pull request. And looking at this list, we can see Lambda, we can see Google Cloud Functions, Azure Functions, but there are other interesting platforms as well that are coming out, like Standard Lib, there's Auth0 Webtask, there's Spot Inst Functions, so it's really growing. There is also a wealth of frameworks for serverless. Of course, the serverless framework is on the list. It's the most popular and well-known framework out there. Originally designed by Austin Collins, it has become a very popular tool in the serverless community, and it's used by startups and enterprises alike. And of course, there are other interesting frameworks like Apex, designed by TJ Hollowaychuk that I just mentioned before. Chalice, a Python serverless micro framework designed by AWS. Gloria.js was created by Gochko Edzik, who spoke at ServerlessConf London and wrote a few books. There's the Lambada framework, there's Sparta, and of course there's the serverless application model, SAM. I heard that SAM was named after you. Is that true?
That's absolutely true.
True.
Yeah.
Excellent.
Absolutely.
And look, I urge you to have a look at those frameworks and adopt one of them yourselves if you are going serverless.
And they all have different takes. Some of them are trying to be all-encompassing, multi-cloud deployment systems. Some of them are just trying to be as simple as possible, like simple and elegant. So, you know, you can pick and choose.
Yeah. I wrote a joke that says, friends don't let friends do serverless without a proper orchestration and deployment framework. Yeah. But I don't think that works.
It's a terrible nerd joke.
Yeah, sorry. I thought I'd try it anyway.
Yeah.
Naturally, there are a lot of other additional services that can be used with your serverless application. You know, this can enable you to go much faster, so you don't have to recreate the same kind of commoditized functionality over and over. So, you know, you want to do authentication? Check out Auth0, check out Cognito. You want to do payments? Stripe, Braintree. So all these services are available for you to use. Databases, go to DynamoDB, have a look at Firebase, have a look at FaunaDB. For search, go to Algolia, and there are other similar services. Yeah. And finally, there are a heap of interesting projects and products on GitHub that you can kind of have a look at and learn from. LambCI is one of my favorite ones. It's the continuous integration system built on Lambda. Check it out. It's a great project just to have a look at the way it's been built.
It's cool.
And finally, alongside projects on GitHub, there are video tutorials, books, white papers, blogs that can help and teach you how to build serverless applications. So I'm sure you'll find something on this list that you might like. So yeah, go check it out, and hopefully there'll be something useful for you.
I thought you were going to put your own book at the top.
No.
Yeah, so, and there's a lot of meetups. So wherever you are, there's probably a meetup near you. There's hundreds of them now around the world. And they're all on meetup.com. ServerlessConf as well is a great way to go and connect with the community. But the meetups are everywhere, like DC, Singapore, Vienna, Israel, Munich, Idaho, Tokyo, just everywhere. We run the Melbourne, Sydney, and Brisbane meetups, serverless meetups, and they're really popular. They actually get a similar turnout to the AWS meetups in those cities. And the thing that's really cool is the crowd there are totally mixed. You get like Google Functions and Google Cloud people, you get Azure people, you get IBM people, and they're all coming together and talk, because they're all solving the same problems. Like server architectural patterns and problems are the same regardless of which cloud you're building for. So it's always a really diverse group. So I would suggest going along to a meetup near you. And then, so this is a really cool graphic that we found online that we really liked, and it's really like, what is the state of serverless and what has happened in just 2 years? It's really 2 years this has all happened in. So if you have a look here, in terms of platforms, all the major cloud providers now have function as a service offerings, and a bunch of small startups like Standard Lib and what's the other one? Yeah, Standard Lib and Spotinst have their own. Everyone has a slightly different take or unique selling point, and there's very fierce competition between the fast providers, which is driving innovation really quickly. There's also a lot of technologies in the enablers space, a little that Pete talked about before. So these are companies that enable you to work faster and more effectively with the underlying serverless platforms, doing things that they don't do yet. So Apex Serverless Framework, Sparta, Stackery, Zappa, all of these. SNCC, is that how you pronounce it? I think. SNCC. I never know how to pronounce it. SNCC and PureSec are really good from a serverless security perspective, helping you secure your serverless architectures and go for least privilege, and a lot of really interesting stuff happening there. And the users are not small companies. You've now got Netflix, Airbnb, Expedia, Rovio, Adobe, Nordstrom. These are big organizations.
A Cloud Guru.
A Cloud Guru, of course, the biggest organizations in the world. So I think the proof is in the pudding. Serverless is providing a strong value proposition for these companies to save money and move faster. So, as we promised, we're going to talk about the community. So the community around serverless has been strong right from the start. Advocates for serverless and the early adopters believe really passionately in the power of these architectures and these approaches. But interestingly, they're not all fanboys and fangirls in this community. They're really not. And that's what I love about it. There's a really strong pragmatic streak here. Half of the talks at ServerlessConf are basically rubbishing serverless. They're talking about the problems they've had and sharing challenges and then coming together to find common solutions. So it's really, really good. These are some of the most active people in the community that we know of who have been involved right since the beginning. And I highly recommend taking a picture of this slide and following these amazing engineers on Twitter. We've got the likes of, say, Tim Wagner from Lambda, who kind of invented Lambda, Rob from Nordstrom, Marcia from Rovio, Ryan Brown from Ansible, Ben Kehoe from iRobot, and many, many more. So we reached out to a lot of these people in the community and asked them for their best tips. We told them about this talk today, and we said, if you could share one thing, what would you share with the community to someone wanting to get into serverless? So we can't go through them all, but I do want to highlight a couple. So Lynn Langert, I love this one. Serverless SQL is a real thing already. And this is such an interesting innovation to me. Like Amazon with Athena, Google with BigQuery, you can now write typical relational SQL queries over petabytes of data without ever having to set up a database server. So with Athena, you're actually querying data in your S3 object. So basically files. You're querying over JSON files, CSVs, text files, and more, and you've never had to set up a traditional database server. And the coolest thing is you can set this up in minutes, and there's just nothing to manage. It's truly mind-blowing the power that you get. I think that's really cool. Yeah. Rowan Udall, sorry, I pronounced it wrong, says, embrace idempotence. It will make your event-based life so much easier, and I couldn't agree more with this. So idempotence means that you can run the same function multiple times, always with the same result. So it means you aren't relying on state in your functions, and it's a godsend when you're building event-driven systems. It means you can build these robust pipelines of events that are much simpler to manage, because if something fails, you can just replay the events and guarantee the same results at the end. And Ben Kehoe from iRobot says, for any piece of technology or software, always ask yourself, does owning this deliver value to my customers, or can I find a service to do it for me? And that very much rings true to me. As I mentioned earlier, that's one of our core principles. And it's the reason we were able to build such a powerful learning platform with just a very, very small team early on.
That's right. So Rob Gruhl from Nordstrom, instead of sending us one tip, sent a huge list of tips.
Rob.
It was great, but we had a problem. So Sam and I debated which one tip do we choose from this long list of tips. So we debated, and we couldn't come up, to an we couldn't come to an agreement. So
we'll give you half an hour now to read them all.
Yeah. So we decided to have 2 slides worth of Rob's tips. I'm not going to go through them all, but please take photos of this slide and the next slide, because, to me, these tips are awesome. They are gold. Just the 2 tips that I want to highlight on this slide are, number 1, every deployed Lambda is a scalable security attack surface area, right? This makes it especially important to use least privilege IAM roles, right? consider using a least privilege policy auto-generator like the PureSec tool. And look, that's a really great tip and a great security practice. Make sure that your IAM roles have the minimum set of permissions required for your function to run, right? You don't want to allow your function to do more than it should. The other tip is avoid kind of the jumbo omnibus lambdas with internal routing. Eric Erickson, who works with Rob, explains it in more detail, and he says that omnibus lambdas kind of make deployment packages a lot bigger and cold starts a lot worse. Because they sum up the dependency and code bases together in a single Lambda package. And this omnibus approach mixes models. It introduces a lot of unnecessary glue code, which makes things actually slower to start up and harder to manage. So that's another good one to think about.
There's more.
There's more. This is the last one, I promise you. Another tip, and this one I done before. So this is beware of serverless cancer. So this is where we should trademark this. Yeah, well, it's Rob's term.
Don't.
This is where one event causes another event to trigger. And it kind of just propagates and escalates out of control. And like you might see it when you use an S3 bucket and you create a file and you have a Lambda which triggers on this new file. And then that Lambda function creates another file and writes it back to the same bucket. And then it triggers again, right? So you get this kind of like endless loop where the Lambda function creates a file, triggers again, and just runs in a circle. And I know I've done it before, and yeah, so just watch out for that. So yeah, please take a screenshot of these tips. I think they're really useful.
So another thing we thought would be useful for you all to be able to go away from here and with some good learnings and carry on is to show you some popular talks and some really interesting talks, because there's been some great speeches and talks at different conferences, and we want to highlight some for you. So these are some talks from 2016, and these were really impactful talks from thought leaders that really influenced the direction of community, and I think influenced a lot of what was built last year. So I'll highlight a couple of my favorites. One was from serverless to service full, how the role of DevOps is evolving. And this was from Patrick Dubois. Patrick is generally credited with coining the term DevOps and is the founder of the popular DevOps Days conferences. Great guy. In 2016, he came to our conference and he talked about how the true power of going serverless is in going service full, like I talked about earlier, effectively kind of weaving together all these third-party services using function as a service technologies kind of as the glue to hold them together. I'm torturing that analogy because you don't weave with glue, but we'll go with it.
Sounds good.
Yeah, sounds good. Yeah, so by going service full, you're leveraging the work of others, right? But going service full, as Patrick said, is not all rainbows and unicorns either. You have to now do your homework. You're bringing these services into the fold, like you are relying on them. So if your system fails, like if they fail and your system fails, then you are ultimately responsible. Like your customers don't care who you were relying on. They care about what they were paying you to do. So you've got to really think about that. And that kind of leads into a great talk from Charity Majors from last year as well called Serverlessness, No-Ops, and the Tooth Fairy, where Charity says that if you have to consider that these companies are now part of your ops team. So Amazon's ops team are part of your ops team. And Pete will go into it a little bit later and talk about it more.
I will, yeah. And by the way, all these talks are available online. You just need to go to Google, type in a name, and you'll find it on YouTube or our platform. And you can watch them in your free time.
They're all free. It's too hard to give links for all of them.
Yeah, so you just need to type in the name and you'll find it. So these talks were given this year, and look, again, it's so hard to choose just a couple of talks that were good. They were all excellent. Well, a lot of them were excellent. Florian is an advocate for better tooling, and he had kind of his point was that great tooling will make serverless succeed. So he had an interesting talk with a lot of insight. Less is More by Paul Johnston was a great talk he gave at Serverless Conf Austin. Paul is now actually a senior developer advocate at the AWS Serverless team, so congratulations to Paul. And his talk is really worth a listen. The serverless security talk given by Guy at Serverless Conf Austin as well was excellent, and he described ways in which serverless systems could be compromised, in which ways Lambdas could be compromised, and how to kind of deal with that. And Avi Schulman kind of expanded on that theme in New York and spoke about minimizing kind of that, the surface area for potential attack. And of course, there was a talk by Ben Keogh where he spoke about event-driven architectures. Great talk. I actually love all talks by Ben, especially the one where he mentioned that Node is the wrong runtime for FAS. It's the wrong runtime for Lambda. So I kind of agree with that.
Yeah, I actually kind of agree with him, but we still use Node. So
we still use Node, so it doesn't matter.
Too late.
Yeah, and check out Sam's talk on the history and building of a cloud guru. It's actually really good as well.
Cool. Yeah, so there was a great talk. This is 2017. There was a really good talk this year by Tim Wagner, who's the GM of Serverless at Amazon and kind of the inventor of Lambda, really. And this guy, Pete.
Hi.
And it was about serverless design patterns. I really like this. It's kind of more computer science kind of theory, but it's really, really good. So during the talk, they actually announced that they're writing this book on serverless design patterns. And what they're trying to do is you know, the original Gang of Four kind of patterns book that was written back in, I don't know, was it the 80s, or I'm not even sure when. They want to build this kind of one handbook for architecting serverless applications. So these are the serverless patterns that can be reused when building distributed applications. So we're already seeing these common patterns emerge in the community now. There's a good handful of patterns that everybody's using to solve the same problems over and over. There was a lot of talks this year on migrations, because I think a lot of companies are now starting to go through this journey of, you know, everyone had to migrate to the cloud first, right? And everything was about cloud migrations. Now it's about serverless migrations. So there's a cool talk. If you're worried about vendor lock-in, and everybody's saying, but if I go serverless, like I'm going to be locked into Lambda. There's a really fascinating talk from Linda Nichols called Break Up With Your Server, but Don't Commit to a Cloud Platform. And Linda explains the problem of lock-in and commitment through the lens of Taylor Swift's relationships and breakups. It's really entertaining. And then she gives some options for those who are worried about vendor lock-in and what they can do. So using either containers as an approach to make something that's portable between clouds, or even multi-provider frameworks. So Linda actually does a demo. She builds an application and then in serverless framework and deploys it out to Google, Azure, and AWS, all within the talk. So it's really cool. And for a really good, like, real-world story of going serverless, check out Pains and Gains on Migrating to Serverless by Marcia from Rovio, and how they did that with Rovio. It's very cool.
Yeah, it's a great talk. Look, this is just my opinion. I think these are the kinds of topics that we will see next year come up when it comes to serverless. I think we'll see a lot more use cases, kind of focusing on startups and enterprises. We will obviously see a lot of talks on security and operations, patterns and architectures as well. I think it's actually one of the barriers that is holding adoption of serverless at this stage. There aren't enough great reference patterns and architectures that people can take, look, and learn from. Yeah. And there's to me, there's a lack of discussion about how to design and build truly scalable systems, kind of beyond just trivial applications that we play with. And how do you manage like complexity of a distributed system? Because all serverless systems are distributed systems. Absolutely. So there'll be, I think, like more conversations about that as well, with the focus on serverless. I think human factors will continue to play in an important role as we kind of continue to discuss ways to persuade senior management that serverless is the future of serverless architectures. And of course, there'll be talks about building resilient software and multi-cloud architectures. Anyway, that's my opinion. I think we'll see, those topics come up next year.
Cool.
Yeah. All right, next one.
Okay.
All right, awesome. We have a special treat for you. We are going to take a little break, but I would love to welcome Helen Garcia, who will tell us the story of his serverless startup and what his team was able to accomplish using serverless technologies.
Thank you, Pete.
Thank you so much.
Thank you. Thank you, Sam. Nice. Well, good afternoon, everyone. Thank you. It's an honor for me to be here with you. Today, I like to tell to you about CityWallet and our migration process to serverless. My name is Ramon Garcia. I've been working with Amazon since 2010, and right now I'm the infrastructure lead at CityWallet. CityWallet is a startup from Venezuela that was born late in 2015 in a really difficult moment for the country, right? Hyperinflation, massive migration of high-skilled people, cash scarcity, and constant currency devaluation. It sounds crazy, but this crisis created the context that made our services useful and possible, right? At CityWallet, we want to make micropayments simpler, faster, and more secure. We want to build the first IoT payment network for countries like Venezuela to allow citizens in those countries to pay for services without cash. So with a vision in mind, we tried to find out a way to start. And we realized that people in Venezuela were spending more than 3 hours making lines to pay for parking, right? So we built our first infrastructure to support the services. And I found a really nice example in nature for the build infrastructure that we built. You know, I present you Mount Augustus. We built that huge monolith to serve that purpose, right? But it wasn't that bad. Our first infrastructure was an hybrid infrastructure. We installed an on-premise infrastructure on our clients. We install an NFC reader, and we provide our users with an NFC sticker they present to the reader to pay. So they go in and out to the parking lot without paying, without cash or making any lines, right? Our cloud infrastructure, we were using Route 53 to manage our DNS, CloudFront to serve the static content, and ELB to load balance the traffic to our EC2 instances in different availability zones. Sadly, we were using MySQL hosted in EC2 instances. But it wasn't a complex infrastructure, right? It was simple, and we thought it was going to be easy to manage and maintain. So fast forward 6 months, and we signed 2 contracts with 2 of the biggest malls in Caracas, in the capital of Venezuela. And 2 weeks after that, we had more than 700 users on board, right? It was nice for an startup, but it wasn't beauty at all. Our clients started requesting new features and reports. Bugs started to appear on-premise and on cloud. Fixes in critical flows, like user onboarding, were added. And monitoring at all levels was required, right? The thing is that all those things are nothing extraordinary, right? That might happen when you go live in a new product. But we could not deliver because our internal processes were taking hours. Like, for example, troubleshooting, fixing, releasing, and deployment processes took us hours because of this huge monolith. Remember, we had two infrastructure, right? One on-premise and one on cloud. We had to scale the whole thing regardless of the traffic, of the type of traffic. It didn't matter if it was payment transactions or user visiting our application. We had to scale the whole thing. And I made this joke about database synchronization because it was like my son when he had 3 years old. I had always to be watching for him to behave. And all these things were making us so busy that we couldn't attend new feature requests or include fixes in a timely manner, right? It impacted us big time. We almost lost some of our clients. We had to stop contacting investors and potential associates. And new ongoing on-premises installations were halted. I don't want to talk about a group of users that created a Twitter user profile to say nice things about us. But after a few days, we knew what we needed. First of all, we need better design principles, not only for our software, but also for our infrastructure. We need to be faster adding fixes, and for that, we need smaller units of code. We need to include CI and CD processes. We need to measure everything, and we need to build less things. You know, we don't have to build everything. We have to excel at integrating services and automation. And I put it three times there because it's really important. You have to automate everything, from for the construction of your software to the deployment of new versions and the deployment of your infrastructure resources. And at that point, we thought that serverless, not only as the Amazon Web Services technology, but as the model, was going to take us there. But we needed a middle point, an intermediary to get there, avoiding more interruptions. So we built our first transition infrastructure to get there. On-premises infrastructure didn't change, but now on cloud, we kept using CloudFront to serve the static content, but now it was hosted on S3, right? And we moved all our databases to RDS instances in a multi-availability zone schema, right? And we started using the benefits of Elastic Beanstalk to deploy new versions of our applications. But the most important part of the infrastructure here is the API gateway, because it allows us to build this layer in front of our current infrastructure and create endpoints that points to existing services or functions in our backend, right? And start dissecting it and transforming them in microservices. And when our whole flow was ready, we just changed the API endpoint to the new service, which is finally a Lambda function, right? So this was amazing because we could do that in 3 weeks, right? We changed all that monolith into a microservices architecture in 3 weeks. And this transition infrastructure allowed us to improve and create our second infrastructure. At first, it can be like a complex infrastructure, a more complex infrastructure, but the reality is that it is easy to maintain, easy to change, and evolve. So we started removing software that we created, like modules to manage the complete user life cycle. So we removed all that and introduced Cognito. And we now use Cognito to register, authenticate, and manage the user life cycle. We keep using API Gateway, but all the endpoints are now pointing to Lambda functions, right? And on the on-premise infrastructure, on the MVC readers, we installed CloudWatch logs agent. And every payment transaction there gets written as a log that is automatically uploaded to CloudWatch. And then we have a consumer, a Lambda function, consuming those payment transactions and triggering another Lambda transactions in parallel. Right? So this is an event-driven architecture that we don't need to scale manually. And we changed our database model, and we are now using DynamoDB schemas. And of course, for the deployment of our infrastructure, we're using CloudFormation. So we now treat our infrastructure resources as we treat our software code. We thought this was the end, right? We saw that we can start only creating software and pushing it to this new infrastructure. But reality knocked again. And if you remember, part of our infrastructure depends on the power grid of the client, right? Because we are installed in the parking lots. So if lights went out there, we can keep processing transactions, but they don't get uploaded to the cloud, to Amazon. So it happened, of course. And what happened is that payment transactions start accumulating on premise. And when lights go out, those transactions start uploading to the internet, and it started triggering a lot of Lambda functions that exhaust our DynamoDB capacity. So at that point, we have 2 options. We can do it manually because we, of course, know when that happens on the parking lot, but that's reactive, right? And we couldn't afford the cost. And then we tried to use in auto-scaling, but we figured out that it wasn't answering on time. It's really slow because it's not prepared for this bursts of traffic that are created unexpectedly, right? So what we did is that we introduced a new service. So what you see right now is the same infrastructure, but we introduced SQS. So if you see that Lambda consumer that reads the payment transactions for CloudWatch, it is not triggering Lambda functions right now. So it creates a message from that payment transaction and putting it on an SQS queue. And then we have another consumer that reads all those payment transactions at the pace we want. So we created this fine-tuned controller to process the transactions as separate when they are being created and the time they process. This infrastructure really improved us. It made us better. We are now faster introducing new features, introducing fixes. We are now managing more than 7,000 transactions, 7,000 active users per month that are generating 140,000 payment transactions per month. We are now a team of 15 people, and we are starting a new business unit in Chile related to public transportation. But there's a lot of improvement to be made. We want to include CI and CD. We have to improve that. We want to introduce step functions to orchestrate all the processing that our Lambda functions are performing. We want to transform every MVC reader as an IoT thing in the Amazon Web Services platform. And we're trying to decide to introduce SAM or the serverless framework to keep improving the creation of our resources. And we learn some things, right? We learn that serverless, at first hand, is about people. You just don't go serverless. You have to change the mindset of your team. You don't have to build everything. You have to make your team to think cloud first and excel and integrating services. Serverless is also about principles. You have to design software and infrastructure to build event-driven architectures and test them all. It's also about measurement, about measured processes, infrastructure resources, applications, and user experience. And it's about automation also. You have to automate your building processes, your testing processes, deployment, scaling, and security. So it is automation at all levels. And we also found out a really nice example in nature about what we want to become. This is the archipelago Los Roques in Venezuela. It's like 300 beautiful islands and cays perfectly distributed along an incredible reef. So for those of you that are geeks like me, you can find the similarity with API gateway and all our Lambda functions working in a distributed system. I want to thank my team because it wouldn't be possible without them. Venezuela is a really difficult country to work, but I think we are doing amazing things there to help people and making their life a little easier. But I also want to thank the community because you guys, I see a few faces here, and I want to thank you because you are not only creating and sharing amazing content, you are inspiring us to build and create new things. This is an amazing moment in technology thanks to serverless. So thank you. I would like to answer some questions before the presentation. Thank you.
Thank you. Great. Look, we only have a few minutes left. We just wanted to share kind of some tips and tricks that we learned from designing our own platform. So we hope that these tips and tricks will be helpful. Yep. So, of course, this is an easy one. It's obvious. Learn from and contribute to the community. There are a whole heap of great sources you can go to learn about serverless. You can go to read.acloud.guru. We have a bunch of articles on serverless that we solicited from the community. There's the serverless.com blog. There's the news stack. They have great articles on serverless. So, check them out. They are all great sources. So this is something that Sam alluded to before. At the start kind of the serverless era, there was this notion that, hey, no ops, perfect. AWS will do everything for us. We don't have to do any more operations. Is that right? Wrong. It isn't right. And we, in fact, learned that understanding operations is very, very important if you go serverless. Sam quoted Charity Majors before, where she said, when you outsource a problem, you are still responsible for the results. So when things go wrong with the services you use, it is still your problem. You need to know how to fix them. You need to know how to contact the team, the support team of the service provider that you are using. I also kind of just want to mirror what Helen just said about automation. It's vitally important to have great automation set up. You need to have continuous integration, continuous deployment. If you go without it, you are going to lose, seriously. And so not understanding operations, not considering automation is kind of bad. So please think about those things. So operations are still there. They are just slightly different to what they were before.
And I think this is a key point. Expect to pioneer, because serverless is still a young ecosystem. And look, it's matured a lot over the last couple of years. But if you start to use serverless technologies, you can guarantee that your team will spend time developing patterns, modifying frameworks. It's no like drop-in Rails and Go solution. Yep. It's no nice web forms in Visual Studio. You know, it's different from that. And so we've spent time rolling our own build systems and then throwing them out when serverless framework came out properly. We've spent time building plugins for serverless framework and then throwing them out when those features get rolled into the framework itself. But teams that can overcome working with a young ecosystem like this will really excel. So you will lose some time to building this stuff, to building tooling that doesn't exist. But overall, you'll be able to focus on your product more and less on traditional operations tasks. And I think the key point here is that you'll have a more engaged team, because it's way more fun building tools and contributing to frameworks than it is managing servers and general operations. So you'll have a more engaged team.
Yep.
So I have some surprising news for everybody. You can build serverless monoliths, and it's 100% cool. It's fine. Like, we did this. Our initial architecture was basically this, like very early on. It was serverless, but it was a monolith. It was basically one database, which was Firebase, coupled to everything. But it was okay, right? This got us to market. It created the business. I mean, I built this thing in 4 weeks from a bedroom to get the business off the ground. So it needed to be simple for one person to build and maintain. Microservices would have been absolute overkill. I couldn't have dealt with it. But then it presented challenges, right? So our front end was entirely coupled directly to the database. So how could we add a mobile app? There was no API to call. So that's a big challenge. And how would we scale from just a few developers to 10 to 20 to 50 without everybody stepping over each other and with a single code base and a single database? So it wasn't scalable. So we decided to move to microservices. And so we moved to this microservices architecture where each distinct business domain was represented by a different service, a little microservice. And it's kind of, a microservice is responsible for its own view of the world, its own database, its own API. And this allowed us to achieve a lot of acceleration because you could focus the teams around different microservices. So the teams own one thing, and they're accountable for that one area of the system. And it also allows different services with different scaling characteristics to scale differently. So you could have different read and write throughput allocated in DynamoDB for different services, depending on how often they're called. So this is an example of how our microservices work. So this is what we call the learning record service. So when someone comes on our site and they do a course, and let's say they complete a course, and we want to track whether they've completed it. So their browser will call our API to API Gateway. A custom authorizer is going to run. That's a Lambda function that says, is this person actually allowed to call through, and are they authorized to do this? Once that happens, a Lambda function runs that's responsible for recording that the user has completed this course. And this, I learned this from Paul Johnson at ServerlessConf, actually. This function does one thing. He said every Lambda function should have 0 or 1 data transformations, and that's it. You shouldn't do more than one. That completely changed our whole architecture. So these Lambda functions do one thing. They validate whether this person has actually completed the course, and they write it to DynamoDB. That's all they do. And so now DynamoDB has become our source of truth instead of Firebase. So DynamoDB, using streams, then fires another Lambda function. Once we know it's been written and it's true, Sally has completed that course, it is now true, it's in DynamoDB, we then hang other Lambda functions off that then go and update, say, Firebase, Algolia, all our other views of that same data. So we've moved now the source of truth from Firebase to DynamoDB and behind a versioned, consistent API. that we can call from a mobile app, for example. But we haven't had to decouple the front-end browser from Firebase. It still reads from there. And the beautiful thing about that is it allowed us to migrate towards this new architecture in stages and not a big bang release. We just could not have pulled Firebase out from the entire user interface in one big release. And think about this. We've migrated from a monolithic architecture to microservices without even having to think about infrastructure. So we haven't had to think about server provisioning, web farms, load balancers. We completely changed our architecture by changing a single YAML file in serverless framework that defines the system and hitting deploy. CloudFormation just picks it up, seamlessly upgrades the system for us, and keeps it running. And I think that's one of the truly amazing things about serverless technology.
Yeah. Perfect. Thank you, Sam. I have 2 minutes left and 3 slides, so I'm going to do it. No, it's good. Look, as we mentioned before, automation is vital when you go serverless. Actually, serverless amplifies kind of the need not just for good development practices, but for automation as well. You are not going to be able to manage a wide kind of distributed system without good automation in place. I actually have a talk on Thursday in ARIA. It's an advanced talk on optimization of serverless applications where we kind of go deep. It's going to be a highly technical talk. So if you are interested in hearing more about what Sam was talking before and kind of the architectures and how to optimize your serverless applications, please come and join us. Join me for that talk. The other thing we need to mention is that, look, managed services are moving targets. Things are going to change. You are talking to all these different third-party services, and one day they'll say, you know what, we are going to change the schema, or we are going to change to a different version, and you will have to do something about it. So for example, for us, Firebase made the old version obsolete, so we were forced to upgrade. Yeah. Lambda made the Node 0.1 version obsolete as well, dropped that support. So we had to upgrade to 4.3. You just have to do it.
And you have to, because it's literally your application is going to stop working on this date. You can't put customer features ahead of that. You have to prioritize it.
Absolutely. So while you do get a lot of acceleration and advantage from using third-party services, you also have to keep this in mind, that things will change and you will have to address them. And look, perfect, just in time. We have made it to the end of our talk. We hope that it was useful to all of you. Please, you are the community. Join the community. Let's talk about serverless. Let's write blogs and go on Twitter and kind of discuss. Help each other out. Please come to the session on Thursday. And thank you so much for your attention.
Cheers. Thank you very much. Thank you all.